Today we're Dan and Trevin from Slice Engineering. I've been a long-time customer. I know the company is not born yesterday. I have some history, I can say. And the company started in 2017, right?
That's correct, yeah.
Is there some history behind that, or just starting in 2017, you want to launch a product and see how it goes, or you had some previous experience in 3D printers and 3D printing pieces before that?
So not a ton of experience in the 3D printing industry per se. In fact, none in the 3D printing industry, but I studied mechanical engineering in college, so there's some expertise there just from getting hands-on with 3D printers early on. But most of my experience with 3D printers before starting Slice actually came on the job. So I worked in a medical device manufacturing company where we built mostly, at least for this application where we use 3D printing, we were building surgical implants for spinal fusion patients. So you get in a car accident, break a vertebrae, that needs to be repaired by a surgeon. So we would machine components that would get surgically implanted into a patient, which is, it's not a great... you don't want, it's kind of funny because you don't want anybody to use your product, right? But if somebody uses your product, then it's a great solution. So
pretty hard impact there.
It's a very hard impact, yeah.
Directly on the hardest of the industries, that's healthcare.
Right, yeah. So we were using 3D printing in a prototyping capacity, and mostly for things like jigs and fixtures, tool holding, anything that was sort of not part of the main production process, but was a complement or an accessory to the main process.
Easier the process to
right.
the final product.
Exactly. Yeah, anything that where we could use 3D printing to help speed something up or just make it easier for the machinists and operators to handle tools. That's kind of where we were using 3D printing periodically. So while we were doing this, we realized that there was not a lot of expertise around 3D printing higher temperature thermoplastics like PEEK specifically. And we needed things that would be dimensionally stable while going through what's called an autoclave process, which is a steam sterilization process.
You can talk about it.
Yeah. So steam sterilization, there's a few different ways that you can get something into a clean room. So medical device manufacturing, semiconductor chip manufacturing, all that happens inside of a clean room. So there's should be pretty close to zero bacteria and viruses in the medical case, or in semiconductor manufacturing, chip manufacturing. You want basically zero dust, right? And of course, there's no such thing really as zero of any of those things, but you're trying to approach that standard. You're trying to. And so to get to that level, you have to bring things through a sterilization process. One of the ways that you can do that is with a dry steam. And you basically put whatever you're trying to sterilize into a chamber that is then pressurized, and you pump steam in there. And it kills all kinds of stuff and will help remove particulates.
Nice sauna.
Yes, it's a very, very hot sauna you don't want to be in. So when you put most thermoplastics, when subjected to that process, lose dimensional
how much do they go up in temperature? Just for context.
So it depends on the sterilization cycle, but a typical cycle for tooling would be a couple hundred degrees Celsius for 15 minutes under pressure.
So you need parts that understand and undertake that temperatures and dimension that they don't warp or melt or do stuff.
Yeah. Wow. So it's not just about melting, but also warping or shrinking in sizes, as you mentioned. And the pressure obviously is a component of it as well. So when you're not, if you were to apply, let's say that temperature to a thermoplastic under normal conditions, maybe it could withstand it. But once you add pressure into it, it changes.
It's not a game. Yeah.
Right. Yeah. So dimensional accuracy, high pressure, high temperature. There's only a few thermoplastics that can really handle that type of thing, and PEEK is one of them. Polyether ether ketone. So that's kind of it's a thermoplastic that's been used in medical devices for a long time. And so we thought, okay, this would be a good application. We can make some of our jigs and fixtures out of PEEK and put them through the steam sterilization process, get them into the clean room. Except nobody could do it at the time. This is back in 2015, 2016 when we were playing with this technology, and there weren't really many people in the world that could print PEEK. Maybe you could extrude it, you could melt it, but you couldn't get
3D
you
printed.
couldn't actually 3D
PEEK,
print it, right? You couldn't get something that was going to hold dimensional accuracy and going to bond together, have that interlayer bond strength to actually make a functional part. So Chris, my co-founder, being the engineer that he is, was like, well, it's just a thermoplastic. Like, we can figure this out, you know? So he had a mill in his garage, and a mill, for those that aren't familiar, is a subtractive manufacturing machine. Basically, take a block of something, put it on there, and
he works out from the big block to a tiny
yeah,
piece.
you cut it down. You cut it down into whatever shape you want.
Was it manual G code or was it software?
Not even G code. He's just like manual, all manual.
Okay,
Yeah,
the manual, the back.
Yeah.
You have to have a lot of
Bridgeport.
experience.
Yeah. So my co-founder Chris he's a pretty good machinist, so he could do this all by hand. Anyhow, so he started prototyping things in his garage, and over the course of the next 12 to 18 months, we figured out that the main limiting factor for us, the first problem we needed to solve was the hot end. There are other problems that you need to solve to print PEEK effectively. Heated build chamber,
dimensional and temperature,
right,
consistency.
Right, so there's all kinds of other factors, but we realized one of the problems that we could tackle was the hot end. And so that experimentation led to what became the Mosquito hot end. So around 2017, early 2017, we realized we probably wanted to actually try and market something out of these prototypes that he was building. And so I incorporated the company then. And then in 2018, we'd actually finally built something that we were not embarrassed of to show off to the public.
Yeah, makes sense.
Yeah, and so we built 35 pre-production prototypes, and they weren't really prototypes. It was the first pre-production batch. They were laser marked. They looked okay enough to sell, and we brought them to a trade show called the Midwest Rap Festival. So some of your audience may be familiar with Murph.
Yeah, we're gonna be there this year.
Okay, awesome.
Up there, so
fantastic. Yeah, Slice will be one of the sponsors this year. So
something new?
We'll see.
We'll see. Okay.
So we'll be at Murph this year, and that's where we launched in 2018. Was at Murph. So that was our first kind of public
impact.
Yeah.
Gotcha. Cool. And from there, just scaled.
Yeah, so we've scaled.
So how was the first impact with the first batch and then adjustments? Do you have a lot of customers that just email you and say, "Hey, this is nice," or?
Yeah, so we were. At that point, for actually the next year and a half, almost 2 years, I was still working my full-time day job, and so was Chris. And we were just doing this nights and weekends.
So
So we bootstrapped it.
80, 100 hours a week.
Yeah, exactly.
Gotcha.
Yeah, so it's full-time normal day job and then full-time extra job at night.
The funny part. The nice part.
Well, what's funny is that neither of us had bad jobs. Like, we had well-paying jobs that we both actually kind of liked. Not just kind of liked, but we liked our jobs. But I've always had this sort of I want to start my own thing, and Chris is genetically compelled to invent things, so he's always coming up with ideas and trying to find ways to make things better. And so it was a good pairing for me liking to start and build things, companies, right, organizations, and Chris liking to create products.
Awesome. Cool. So I'm a user of your products, and I use them on Ender machines, and mainly that because I have certain requirements. I don't print PEEK or stuff. I just stop at polycarbonate or carbon fiber because my customers require that and not more. If they ask special stuff, I just send to another one and just be the middle guy. That's the easy job. So, yeah. I was curious about also your new, I don't know, it's very new, the next line that you went after the hotends were nozzles, and that's about the point. And I'm using the Bridgemaster and the vanadium ones, and I like them a lot also for carbon fiber stuff, that they're pretty tough. And what brought you to develop those products and those type of compounds? Because vanadium is not an easy material to machine.
Right.
So what brought you there? What was also the development behind that? So because peak, you don't need that extensive type of hardness and stuff. You just need a good nozzle, but not a very hard one.
Yeah.
If you add stuff, then you need that one.
Mm-hmm. Yeah, absolutely. So one of the things that drives our research and development and product development is really, one, looking at customer needs in the market, and then two, looking at what are we struggling with here in our own lab. We've had several products that have come out of that use case where it's like, okay, there's more and more carbon fiber or glass fiber, there's more fiber-filled filaments coming out, which enable new applications, right? More stiffness, higher strength in certain areas. We've got to be able to print this, and if you've got a brass nozzle that wears out constantly, it's not a good user experience, and it's also waste, right? It's also a waste of money. You can buy a bunch of $3 to $8 nozzles, or you can buy one $35 nozzle that will literally last for the lifetime of your machine. So you end up saving money on the back end. So the idea behind the vanadium nozzle was, how do we build something that is going to last essentially forever? And so we had to look at different metals and say, okay, what is going to resist carbon fiber abrasion for an indefinite period of time? And also under heat, right? Because material properties change with heat and pressure.
That's the part that you don't see, like, oh, it's just a nozzle. Well,
yeah. Right, there's a lot of metallurgy that goes into it, actually. Yeah.
I can imagine.
Yeah, so there's, now we're not forging metal bars or anything, but we
not yet.
Right. So that would be cool if we went super vertically integrated. That would be really cool. But
with the metal 3D printer,
maybe
you never know.
You never know. But we partner with the right suppliers to find the right
compound,
the right alloys that will be able to do what we want them to do. So, I mean, we have a lot of expertise internally, a lot of good solid engineering expertise, but where we don't have expertise, like in metallurgy, for example, we'll go find who's the right guy to talk to in the industry that knows this type of alloy that is
what it can do.
Exactly. Yeah. Okay. So we'll go find that person.
How do you convert it inside a product? Because everything on paper is nice,
right?
And then you do a prototype, and then the outcome is like, we need to adjust some things.
Yeah. So that's always true, no matter what you're building. Every sort of overnight successful thing that you've ever seen has, probably 5 to 10 years, 20 years behind it, right?
Behind the curtains.
Yeah, behind the curtain that you don't see. So yeah, in the case of where we're sort of taking expertise from internally or externally, we're always going to, as you mentioned, build a bunch of prototypes. We're going to test it with whatever the end use application is. In the case of the vanadium nozzles, just to use that as an example, we're going to print a lot of fiber-filled, fiber-reinforced filaments and make sure that it actually does what we think it will do. We're going to run it through different temperature ranges, different materials, different use cases, different flow rates, different retractions, figure out, okay, what are all the settings that affect abrasion, and we're going to run it through a litany of tests to make sure that it does what we think it does. And if it doesn't, you scrap it, try again. Maybe we need a different alloy. Maybe we need a different plating. Maybe
does the shape is the shape important for that? Because I saw that they're made specifically for the V6 ecosystem, but sometimes I find that the final use application, in this case the V6, is not the best one. Maybe there's a longer version that could be better at melting stuff. Is that a case? Has it been a thing?
Sure. So the reason we've stuck with the we call it a rep wrap style nozzle.
Everybody calls it the most common way.
Call it a little bit different. But the reason we've stuck with that geometry is that it is, one, readily adaptable to most machines, so it fits a wide variety of places. And then two, we actually think it is pretty well positioned. Maybe it's not the most optimal, but it is the optimal value per output.
So we can say like it's optimized for the market.
Exactly, yeah, it's
Okay.
optimized for the market. Yeah.
That's a very huge thing in some places. Like,
Yeah.
Gotcha.
Yeah, like we could make, there's certain things that you could do to the nozzle geometry to make it
Enhance performance.
right? But whether it fits everything that's on the market,
That's another thing.
right? It's
Yeah.
a totally different ballgame. So that's an interesting balance always of what is a working product versus what is something that's marketable.
Now there's a lot of companies that get out with other solutions, but I see them break down more often and easier. Also for especially with carbon fiber filaments, there's sort of threads going on now in this period. And is there something about that you tested also on the heat break that made it better than the competition?
Yes.
Because it doesn't happen with mosquitoes. It's like a thing. At the end, you try stuff, and until now, the solution is get a mosquito.
Right.
It's a thing. You can try stuff, they work for a month, 2 months, 3 months, and then it starts just, I don't see it breaking apart, but kind of.
Yeah. So I mean, any mechanical system is always going to experience wear and tear, right? I mean,
Absolutely.
And you could make a mechanical system, a 3D printer that never broke down, but it'd be exceedingly expensive and nobody would buy it, right? And you can go to the total other end of the spectrum and you make a very cheap 3D printer and an inexpensive 3D printer, and you will get the reliability that you paid for. I mean, that's essentially
You get what you pay for.
You get what you pay for. And so, we're criticized for our prices sometimes because, we're on the higher end of the market. And I understand that criticism.
When you start talking that you start with peak and not PLA,
right?
That's already a big spectrum of difference between user capabilities and also expenditures.
Right.
Because if a customer is printing with peak, he has a different type of wallet,
right,
or amount of money that he can spend is better of an ender and a PLA setup.
right.
So just starting there is a very broad difference.
Yeah, I mean, a spool of peak is more expensive than our hot end.
Or their 3D printer these days.
Right.
Like, you had a spool or 3D printer.
Right. So yeah, there's a different sort of scale on price that where the criticism of something being $150 no longer makes very much sense, because, for example, for your business, it's like, okay, if you constantly have failures that you need to repair, that means that you're not working with your clients, you're not building something for your customers that's then making you money. So having the reliability in that case is very much worth spending the extra 30% for, because you are going to very quickly make that up on the back end. I'll give you an example. We recently
with time is money.
Time is money. Yeah, time is money. And you pay for you're paying for engineering expertise, right, that went into that product. You're paying for customer support from people that are knowledgeable in the industry, and then you're also paying for higher quality materials. I mean, that's really what it comes down to. Everything that we've done and everything that we've put into the Mosquito, we're on the 4th iteration of the Mosquito now, and we don't talk about that a lot, but we are constantly making small iterative changes to improve the product.
That's the way to go.
Right.
Yeah, that's the way to go.
Yeah, you think about the Porsche 911 is like the quintessential reliable sports car. Why? Because Porsche's been making the 911 for 50 years. And
they have some background.
Right, yeah. They have some background. They know how to make a sports car. And every year they make slight changes that have improved the car immensely over the course of decades. And so we have a similar thought process and approach for how we improve our products. The stuff that's coming off of our production line today is significantly more reliable than the stuff that came off of it in 2018. And the stuff that comes off of it next year is going to be more reliable than the stuff that's coming off of it right now.
The next thing I want to talk is about the new development for the current 3D printers and new 3D printers. There's a lot of talk about new 3D printers, like there's the Fluid Excels coming out.
It's exciting.
It's gonna be a big thing, maybe.
Yeah,
we'll see. Are you gonna develop something for that type of environment, or do you have other printers that are gonna support more in the future? Because now we have support with a lot of printers out there.
Yeah, so we're always looking at new 3D printers and how we can best support them. The challenge, of course, is there's so many on the market that we can't, with our relatively small but growing team, we can't tackle every 3D printer at the same time. But as an example, we're working on a solution for Mark Forged machines. We're working on solutions for some of the Race 3D machines. There are a lot of new machines that are coming out that we are working on solutions for. And in some cases, we're working in an OEM capacity as a supplier, but also in many cases, we're working as an aftermarket opportunity where we're seeing, okay, the machine comes out, and then we'll wait for market feedback. We'll wait for people to say, oh, okay, this machine needs a new nozzle, or it needs a better heat break, or maybe the sensor dies really easily or is very fragile. So that's really where we see the opportunity to help improve that product and make it more reliable for our customers that are buying that particular machine.
Okay, gotcha. I want to talk about R&D. You have several patents, and I went to a patent process in my life, and it's pretty painful, to say the least, and expensive.
It is.
And when you acquire a patent or you have granted a patent, then you have also certain costs. But not everybody respects that.
Yeah,
I see a big problem with everything being free. Like software on cell phones is free. Why do I have to pay for a patent, or why do I have to pay for a product that has a patent behind it? So what's your point on that?
Yeah, so patents are, unfortunately, have a pretty bad rap in the rep community, which is, I think,
I know.
In some ways undeserved. But, patents are, unfortunately, super expensive to get. The original intent of the patent system was to protect the individual inventor, and it has become so expensive that now it is difficult for an individual inventor, like where Chris and I were just a few years ago, to actually get a patent. And if we hadn't had savings in the bank and well-paying jobs, there's no way that we would have been able to afford a patent and get everything to market, right? But we knew, because we weren't millionaires that had the opportunity to just dump a bunch of money to grow this very super, super quickly, that we would have a lot of competition very quickly. And
so you already knew this before starting your process?
Yeah, I mean, we knew that there would be competitors, that would try and undermine what we were doing. And I say undermine because there's a way to compete fairly, right? And then there's a way where you don't compete fairly, you don't use the same rules. When we first launch, I guess I'll say whenever we launch a new product, we see a flurry of traffic from certain countries hitting our websites, and we know that they're coming in and they're buying, they're looking at what we've launched, they are buying things.
They're buying your products and you ship them to them, so you know that they're testing your products and
so a lot of times they're buying through they'll get it shipped to a post office
somewhere
or
else,
something, right? But
to don't unclose who is it
right,
doing
exactly.
the work.
But we see that in some of the companies that do this. I mean, they don't just steal patents, they also steal things like trademarks, and they steal copyrighted materials. One of the particular companies I'm sort of not talking about is when they first launched their website, they took the marketing copy that I wrote straight off of our site, they took product photos, they took all kinds of things directly off of our site, made a couple little Photoshop edits and posted it as their own. And that kind of behavior is theft. I mean, that's what it is. It's theft. So people
you wake up a day and it's like, why?
Right. Yeah.
What they do to you.
It's pretty frustrating. Yeah.
And you can't do much.
Yeah, it's difficult when they're in another country.
Yeah, you can't do much, literally.
Right.
Yeah, you can send emails, maybe a letter from a lawyer or something,
Right.
but you can't bomb them.
Right.
Like,
Yeah, certainly not.
so
Yeah. Yeah, it is a frustrating process. And what we found is that people that or companies rather that disregard patents typically also disregard all forms of intellectual property. And so if you are an individual designer, they're just as likely to steal from you as they are from somebody that has a patent. If you are a writer or a content creator, they're just as likely to appropriate your copyrighted content as they are to steal a patent. Because once you start down the route of theft, everything is open.
yeah.
Right.
But I'm curious, do you communicate with them, or do they communicate back, or is just silence?
It depends.
What do they? I'm just curious to know, what do they say? Like,
Yeah. So it's an interesting situation because some of them just ignore any communication from us, and some will respond and pretend like they don't know who we are, or
it's pretty tough.
yeah, or like they've never heard of our product. It's like, oh well, you mentioned our product on your webpage, so that's interesting.
Who wrote it?
Right? Yeah. Who wrote? I remember writing the sentence that's on your website. So. Yeah, so some of it is just games, but sometimes they admit to what they're doing, and they just say, well, you can't stop me,
Because they're another country and somewhere
because they're
else.
another country, yeah. And so in that case, we do what we can on marketplaces like Amazon and eBay, and there's certain other things that we can do as well, but yeah,
There's some limitations there.
There are limitations, certainly. Yeah. So it's difficult for an individual inventor who wants to build something bigger than themselves to. It's a hard fight. Yeah.
Yeah, sure is. And the bad part I start seeing in the last maybe 5, maybe 7 years, that when you want to develop a product, you have to really start with those thoughts.
Mm-hmm.
You can't start with a product that's adjust the road.
Right.
You have to do it before.
Yeah.
And a lot of people that are inventing stuff or producing stuff don't know this, and they learn the hard way. I learned the hard way. It's not fun.
Sorry to hear
it's not fun.
Yeah.
You learned a bit before because you already knew there was going to be a challenge there. This last global issues, shortages and stuff, how do you face it for the current setup, and how are you going to adjust the route for next ones?
Mm-hmm. Yeah, it's a great question. So part of the answer there is that we try to do as much as we can, as local as we can. It's actually
in-house and
right, or in-house. Yeah. Okay. So that's actually one of our core values, is that we try to do things as local as possible. So, for example, my business cards get printed here in Gainesville. Our packaging is made by a company that's not that far away from us. So that helps with supply chain, right? Mm-hmm. Because there's
the right distance. Word is supply chain.
Right. Yeah. And 96% of what we produce by revenue is all done in the United States. And so that also helps to simplify our supply chain by not having, this sort of long global reach. Of course, that increases price. But we found, especially during the last couple of years, when
that's the point,
right? When a lot of our competitors who relied on Chinese manufacturing, they weren't able to get parts when they needed to, and we were for the most part able to. Sometimes we had disruptions, like for a while we were using a plater that does our black anodize on our aluminum parts. They were also doing medical parts, and so they had to hold our stuff. Yeah. They literally had our parts, thousands of our parts, sitting on the dock, and they just would send us pictures saying, "Here are your parts. They're still here, still waiting for medical supplies to get through." And so, obviously, we were, happy to wait in that case for the medical supplies to get through plating first, but it causes
it gets a hit from somewhere. Yeah. Okay. Right. Gotcha. So, can we talk about new products or
sure? Yeah, we can talk a little bit about it.
There's a lot going on in 3D printing industry in the last 2-3 years.
Absolutely. Yeah. So one of our focuses is definitely increasing throughput in 3D printing. So We launched our Magnum Plus hotend middle of last year, and that is really focused on improving the throughput, more plastic coming out per second of a hotend. The Bondtech CHT nozzles, which came out recently, also help with that, and that's a nice, additional flow rate opportunity that you can pair with the Magnum.
Are you
Plus.
developing something similar, or?
So Bondtech actually licenses that technology, so that is a patented technology.
Oh, okay. I didn't know that.
So that's a patented technology. So going back to the patents conversation, we got a lot of heat because we were one of the first companies.
You got all the fire.
Yeah, we got all the fire. But now everybody has patents, right? E3D has pending patents. Bondtech has licensed patents. Pretty much anybody that is in the 3D printer component space like us has patents. In fact, one of the companies that infringes on our patents, Fadis, they have more patents than we do. They're in China, but people don't give them a bad rap about patents, even though they have many patents. Ironically, many of them for things that were patented in the Western world first, in Europe or the United States, and then they went and patented it in China. And now companies that own the patents in sort of the West cannot go sell those products in China. So
because it's another world, another environment.
It's another environment. Yeah. So it's an interesting.
There's a lot of output from there, but not much of input. It's not easy to bring your market there, but it's very easy to them to market here.
Yes,
and that's a bad thing.
It is a bad thing.
There's no fair competition there.
Right. So that is a frustrating component of all of this. But back to sort of new products, we launched a Mosquito boot not too long ago, and then ended up having a problem with the formulation that we had to tweak. So we'll have a new Mosquito boot shortly. We'll have a copperhead boot shortly, which is pretty exciting. And there will be more. A lot of our focus is going to be around solving specific 3D printer problems, as we talked about earlier, like having a specific kit that is a plug-and-play setup for. Right now we have one for the Race 3D E2, for example, for that machine. We have a lot more coming like that are a simple plug-and-play with installation manuals. And that type of approach, I think, is going to be really helpful, especially for novice users or users who don't have a lot of time to play and tinker with.
Or they don't know how to do it.
Or they don't know how to do it.
That's a huge thing.
Yeah.
It's still a huge thing.
Right. Yeah. So that's going to be really our focus in the near future is how do we
bring your current products to more kits around.
Yeah.
Okay.
Exactly.
Gotcha.
Yeah. So that's going to be our focus for the near future.
Gotcha.
Yeah.
Oh, nice.
Trevor, you can talk it all. I answered all the questions. That's not good.
He's a great listener.
Yeah. I'm just amazed.
You're right.
I mean, I can certainly comment on a number of things, but
How's about the marketing part of Slash Engineering?
yeah. So the marketing part is still pretty fresh. We are learning. One of the interesting things that I think Slice has done really well is our team is super diverse. We have a lot of engineers, but then there's a few people with diverse backgrounds. I'm one of those individuals that came in from kind of an e-commerce startup background specifically.
That's perfect.
And so, yeah, I'm just really still sinking my teeth into the 3D printing culture and
Cold, almost.
yeah, well, it's very cool, full of a ton of smart people, and you guys talked a little bit about patents, and obviously there's a lot of heat around that, and so we've been looking into that, and like Dan mentioned, we're kind of a sacrificial lamb, it seems. We were the first ones to make a smart move, and then since then we've been consistently kind of taking the spear for that. And I just want to comment that when you disincentivize patents, you are disincentivizing
Innovation. For
Exactly. Because, like you said, there's this bar of entry where patents are already so expensive, and then if you think, well, they're useless anyway, and even after I innovate and create this new thing, it's just going to get stolen from me. I'm not going to be able to create that business and then further innovate. And as a result, a lot of things aren't ever made, or they're made, and then what ends up happening is the person who made it gets driven out of business, and then you have this lower, cheaper option, and then manufacturing standards get pushed into the gutter, and you actually end up with a lower quality product in the space that you wanted. You wanted something nice, and now you actually have something worse. And so it's a lot of people say that patents slow down innovation. They do the exact opposite. I mean, I see it all the time in the comments on YouTube and whatnot. People seem to hear there's a lot of echo chambers, and
there's a lot of resonance on the wrong topics.
And so people generally, even if they know very little about 3D printing, like myself, who I'm still learning, but they will jump into a forum, and then they hear some back and forth about negativity and patents and this and that, and they want to immerse themselves in the culture, and as a result, they'll end up sharing a very similar opinion, and it's just not exactly helpful. It's not constructive.
Absolutely. Okay, gotcha. So guys, it's been awesome to see you, and I'll see you in the future.
Yeah.
And have a good weekend.
Yeah.
Thank you.
Thank you, Rich. It's been a pleasure.
Yeah.
Awesome.